So in this video, we're going to talk about how to calculate the pH of a strong acid and a weak acid. So first, we have a strong acid on the left-hand side, and we need to calculate the pH of a nitric acid. And we're told that the concentration of the acid is this. So this is pretty simple question. You just need to use this equation. pH is equal to negative log of the concentration of hydrogen ion. In order to know the concentration of hydrogen ion, you can use this equation. HNO3 is dissociated into H plus and NO3 minus. Initially, we have 0.5 times 10 to the negative 2 molar of the acid, and we assume that all of that is dissociated. All of the acid is dissociated into hydrogen ion and NO3 minus ion. So in final, we will have 0 molar of the acid and 0.5 times 10 to the minus 2 molar for each product. So we just need to plug this into this equation. Then we know the pH of this solution will be this one, which is calculated to be 1.82. So here's our next problem, the weak acid problem. We need to calculate the pH of the weak acid for a 0.5 molar of aqueous solution. So we can write this equation. HF is dissociated into H plus and F minus. Since this is a weak acid, the HF acid will be partially dissociated, which means, unlike the case in the strong acid, where all of the acid is dissociated into its ions, only some of this acid will be dissociated, and some will be left in this acid form. So this is a little bit more complicated. So we can form this table. So initial will be 0.5, and we assume initially there's no dissociation occurs, so 0 molar for each product. Then the change will be, we don't know how much of the acid will be dissociated, so we're gonna call them an X amount, and the X amount will be formed for each product. Then we can tell that the final will be just addition of these two guys. Then we have 0.5 minus X molar, and here we have addition of these two guys, so it will be plus X molar and plus X molar. The next step will be using the Ka value. The equation of Ka is H plus times F minus and HF. So we just plug that in. So this for H plus, this for F minus, and this will be HF. So the result we have will be x multiplied by x divided by 0.5 minus x. And that is equal to 7.2 times 10 to the negative 4. Just like shown here. So this is a pretty easy algebra. So I'm just going to simplify this equation. Then we have x squared divided by 0.5 minus x is equal to 7.2 times 10 to the negative 4. Then we can move this to on this side. Then we get x squared is equal to 7.2 times 10 to the negative 4 multiplied by 0.5 negative x. Then x is equal to minus 7.2 times 10 to the minus 4x. Then we can use the quadratic formula. Then we get the x is equal to 0.0186 molar. But remember, our x is equal to the concentration of the hydrogen ion, which is also equal to the F ion. So I'm just going to write it down. This is equal to the concentration of H plus ion. But our goal is to calculate the pH. Remember that. Our goal is to calculate the pH. So how do you calculate the pH using the concentration of hydrogen ion? We can use this equation. pH is equal to minus log of H plus. Then we just plug that in, plus this value into H plus ion. Then we get minus log of 0.0186. Which turns out to be pH is equal to 1.73. But there's a much easier method, which requires one assumption. So I'm going to run through that. So I'm just going to write down pH is equal to 1.73, and I'll show you the easier method. So erase this. So in this situation, we're going to assume that 0.5 minus x is approximately the same as 0.5. This is because we have a weak acid. So what does weak acid mean? Weak acid means that the acid is partially dissociated into H plus and F minus. Most of the molecules will be stayed as HF molecule instead of H plus ion. Then we can safely conclude that the X is significantly small, that we can approximate that 0.5 minus X is the same as 0.5. So what does that bring to us? Then we can simplify this equation. Then we have x squared divided by 0.5 minus x, but we assume 0.5 is approximate to 0.5. Then it is equal to 7.2 times 10 to the minus 4. Then I'm going to bring this to this side. Then we have x squared is equal to 3.6 times 10 to the negative 4. So this time we don't need a quadratic formula, which saves us a lot of time. Then square root on this both hand side, then we have x is equal to 0.0189, then the pH will be negative log of 0.0189, which is the same as 1.73, which is the same as this one. Yep, so I hope it helps. Feel free to leave the comment for the next video that you want me to cover, and thanks for watching.